Hi ladies, so this would be lesson 4 on geometry 2, and it is more theorems involving triangles this time. Now, just to kind of give you a bit of I suppose, an update, like theorems in this case, you don't have to learn them, like you don't have to know, oh, theorem 4 is this, or theorem 1 is this, or theorem 6 is this. You just have to know when to use them. Like, I suppose, like if you want to describe alternate and corresponding angles, you know that they're equal to each other because they're alternate and corresponding to each other. So that would be the theorem. Same with your vertically opposite angles. That'd be theorem 1. And theorem 1 states that vertically opposite angles are equal in length once they have two lines that are intersecting at a point and creating kind of the letter X. That's another way of just maybe giving a reason why they're equal to each other based on a theorem. So the first thing that I want you to think about is, where do you see triangles in everyday life? Okay, so as I said here, triangles are often seen in construction as they are a very stable shape. Okay, so have a look around your house, have a think about constructions that are outside. Where do you see triangles in everyday life? Okay, so I'll give you maybe a minute to think about where you see triangles first of all. Okay, so write down a few, and I'm going to show you some triangle shapes that I've come across in construction. So this building here is triangular shaped, and it looks quite modern, doesn't it? But it's obviously constructed because it's fairly stable. A roof as well. A lot of roofs have a triangular shape in it because they stay up. And a bridge. So this I think is I think it's either Brooklyn Bridge, or it could be the bridge in San Francisco. And you can see all the triangular shapes that are involved. There's one across from the other, right? And it's the construction of a bridge is usually in the shape of a triangle because it holds well. Okay, so triangles then. So angles in triangles. What do you know about angles in a triangle? So we've types of triangles first of all, and these are ones that you would have come across in primary school as well. So what are the types of triangles? Okay, so the first one is an equilateral triangle. And what are the characteristics of an equilateral triangle? I'll just zoom in there. So an equilateral triangle, 3 equal sides and 3 equal angles, okay? So this tick here, this tick here, this tick here are all the same. So that means that all the sides are the same. So therefore all the angles are the same. And in this case, all the angles would be 60 degrees, because when we come to it, what you know about all the angles in a triangle, they add up to 180. The second type of triangle is an isosceles triangle. And what is the characteristics of an isosceles triangle? So first, let's study the triangle. What do we notice? Okay, there's a tick here and a tick here that are similar, or the same. So therefore they must be the same. There's 2 ticks here, so that must not be the same as these 2 sides. There's also 2 blue dots here, so they must be equal in length. And we have a yellow dot up here, which is not. So what are the characteristics of an isosceles triangle? There's 2 equal sides and 2 equal angle bases, okay? So 2 equal sides and 2 equal angle base. So that means the opposite sides are equal and the opposite angles are equal then in a case. The third type of triangle, can you remember it? So you have an isosceles, you have equilateral. I think equilateral has the word equal in it. What would be the last one then? It's a scalene. And let's have a look at the diagram first of all. What do we notice? Okay, that all the sides do not have the same tick on it, so they must all be different, and all the angles must be different as well. So that's the characteristics then. So 3 unequal sides, or 3 different length sides, and 3 unequal angles. Okay, so it would be a good idea to maybe write those down and draw a little sketch of them and put underneath what each one is. Okay, so any triangle containing a 90-degree angle is a right angle triangle. Okay, so any triangle containing a 90-degree angle is a right angle triangle. We've come across this already. So this is what they look like. And obviously, if the 90-degree angle is not put in it, then you can, the symbol for it, I suppose, is like a box. Okay. An isosceles or a scalene triangle may contain a right angle. So look at these. This is an isosceles triangle and one of the angles could be 90 degrees and you have the box shape here. Another isosceles triangle. This would be a scalene triangle. So right angle isosceles triangle and right angle scalene triangle. So remember, isosceles, two the sides are equal, opposite. So if we knew this was 90, we'd be able to work out these two. Right angled scalene triangle, all the angles will be different, but one of them happens to be 90 degrees here. Okay, so this is just a brief introduction to Theorem 2, and it's based on the isosceles triangle. So a little background information. So where does the word isosceles come from? So it derives from the Greek iso, meaning same, and skelos, mean leg, because it looks like human legs. And I suppose what they mean is like, this is like the body part up here and your legs are kind of standing out. And obviously, in general, our two legs are the same length. So this would be the same, this would be the same. So that's where it comes from, which is kind of interesting enough. And it says a triangle which has two equal sides is an isosceles triangle. So you don't need to take down the background necessarily, but I'd like you to take down Theorem 2. Okay, so what does Theorem 2 state? In an isosceles triangle, the angles opposite the equal sides are equal. Conversely just means like reversely, or how we can say it in another way, is that if the two angles are equal, then the triangle is isosceles. Okay, so in an isosceles triangle, the angles opposite the equal sides are equal. So if you were asked a question, you were given this measurement, and you're asked what's the measurement of the angle that's beside it or opposite it, you'd be able to say, right, from my theorem, I know that in an isosceles triangle, the angles opposite the equal sides are equal. So therefore, that must be the same as that. Okay? So to determine the angle sum of any triangle, right? So this is just a little kind of, take three identical copies of this triangle like so, right? So we're going to put down three, I suppose, triangles of this type. Put them together like that, right? How can we use this to help us, right? So this, you do not need to take this down. This is just something interesting to come up with the sum of all the angles in a triangle. So we know that on a straight angle, that angle plus that angle plus that angle must equal to 180. Don't we know that? So the orange box, the yellow circle, and the kind of red, pink, I suppose coral, if you want to look at it, triangle. So angles on a straight line add up to 180. These are the same angles as in the triangle. Look at the three angles in a triangle. So therefore, the angle sum of a triangle must equal to 180 degrees. And what that means is each of the angles in a triangle added up together will always sum to 180. And remember, that was one of our axioms as well. That was axiom 3. It's based on a statement that we accept without proof, but also it can be based on a theorem as well. So calculating unknown angles, right? So this angle is 65 degrees. We need to work out angle A. What do I know this angle is equal to? Equal to 90 degrees, right? So angle A would be equal to 180 minus 90 plus 65. Angle A then is equal to 25 degrees. So take down these examples. Do a little sketch of the triangles as well. Example 2, calculate angle A, B and C. So let's have a look. What type of a triangle is this? All the sides are the same, so it's equilateral. So all the angles must be the same as well. And what do you know about all the angles in a triangle? What do they add up to? 180 degrees. So 180 degrees divide by 3 and you get 60 degrees then, don't you? So angles A and B are 60 degrees and that's got from 180 divided by 3. Okay, let's look at this example then, right? So another good example to take down. So what type of a triangle have we got here? Okay, so this tick is the same as this tick, so they're the same as each other. Opposite angles are equal then. So straight away, this is an isosceles triangle. What do you know about an isosceles triangle? The angles that are opposite each side are equal. Okay, so that's 65 degrees, that must be 65 degrees as well. So angle A is equal to 65 degrees. Base angles of an isosceles triangle are equal. And then how would we get angle B? So we know as well that the three angles in a triangle add up to 180. So it'll be 180 minus 65 plus 65, which will come out to be 130, and that will give me 50 degrees. And finally then, example 4, calculate angles X and Y. Again, what type of a triangle have I got here? So that side is the same as that side. So it's an isosceles triangle. So these two angles must be the same. Right, let's figure out how we'd work this out. So I know that plus that adds up to 180, don't I? So if I took 130 away from 180 and then divided my answer by 2, that would give me x and y. So it's 25 degrees then, and they must be the same because it's an isosceles triangle. Okay, example 5 then. Now you don't need to take down all these examples. I say take 3 of them, okay? Okay, we know this is 90 degrees. We know this angle is the same as this angle. A and B, right? So opposite angles to the equal sides are also equal in measure. So that's 90. I definitely lost 90 from the symbol. So if I take 90 away from 180 and then divide my answer by 2, that will give me A and B, 45 degrees. And finally then, calculate angle A. So we got 6 examples here. You may take 3 or 4 of them and write them down. So example, right, what do I know now that the 3 angles in a triangle add up to 180? So if I add these 2 together, take away from 180, I'll get 138 degrees to be A. Okay, so this is another example here. You could have a look. So find the measure and just how it's wrote of angle. When they use the straight brackets, remember that means the measurement. If they didn't use the straight brackets, it'd just be naming the angle. But they're asking you to find the measure of angle ABC. So ABC. So again, what type of a triangle is this? It's an isosceles. The 2 sides are equal with the similar ticks on them. So these 2 angles must be the same. So if that's 40 and that's 40, right? That'd be 80 then, okay? And if I take 80 away from 180, I would get this angle here then. So 40 plus 40 will give me 80 because that angle must be the same. But remember, I'm looking for angle ABC. The letter that's in the middle refers to the angle that I'm looking for. So ABC. So that would be 80 from 180, which would give me 100. So this is theorem 4 then, right? And you do not need to take this down, right? But what theorem 4 states is that the measure of the 3 angles of a triangle must sum to 180 degrees. So that is theorem 4, and that's really what you kind of take down. So this kind of just shows you how they came up with it, right? A little proof, but you can have a look at it. You don't need to learn it, okay? That's what you need to know. The measure of the 3 angles of a triangle sum to 180. Okay, theorem 6 then, right? Theorem 6 is based, and this is a new one, right? And you need to obviously take down theorem 6 and what it stands for. So an exterior angle of a triangle equals the sum of the 2 interior opposite angles. So again, this is like a little proof, but again, you don't need to prove this, right? But what it's saying is that this angle here, which is angle 1, is equal to the sum, which is at the addition of the 2 interior opposite angles. So that angle plus that angle. So as it says here, to prove that angle 1 is equal to angle 3 plus angle 4. Now they should have had the straight brackets here to show the measurements, but you do not need to learn off this proof again, right? But you can have a look at it yourself to see how they come up with it. But basically, what you need to take down here is the heading, a little diagram, and you can just write down to prove that, or you can just say that what we know is that angle 1 is equal to angle 3 plus angle 4. Okay? So just to summarize, and this page might be a bit easier for you to take down, theorem 4, the angles in any triangle will always add to 180 degrees. So we have angle 1 plus angle 2 plus angle 3 will always equal to 180 degrees. All right? And theorem 6 then, which is just on the previous page there, each exterior angle of a triangle is equal to the sum of the interior opposite angles. Now think of the word exterior. Exterior means outside. So an exterior angle of a triangle is the angle between one side of the triangle and the extension of an adjacent side. So like this. So this is the exterior angle, it's outside of the triangle. So that angle there is equal to the sum of 2 plus 3. Okay, so if you had these 2 values and you're asked for angle 1, just add the 2 of those together, that would give you angle 1. Okay, so let's look at these 2 examples here, and you can take them down as questions and try them, right? So find the measure of angle C without measuring the angle, right? So isn't this based on theorem 6? What do you know about this angle here? That is equal to the sum of the 2 interior opposite angles. So I'll let you take that down. Now let's look at this one. Find angle 1. The diagram is not drawn to scale. Okay, yeah. So what do you know about this information then? So this angle is the exterior angle. Remember, it's like the angle that's outside the triangle. What's that equal to? It's equal to the sum of these two. So could you reverse that and work backwards and work out that angle 1? So I'm going to let you work those out yourself, okay? And that is basically, I suppose, kind of lesson 4 on triangles, right? So you've got theorem 2, you've got theorem 4, and you've got theorem 6. And I said here, so which triangle is not similar to the others, right? This is just a little thing. This one is not, because what you notice about all the other triangles, they have right angles within them. So that angle doesn't, okay? And then let's look at this one. So what does it say here? What's the question? These two triangles are both equilateral. Are they similar? So equilateral means they're equal. Or sorry, they have all equal sides. Are they similar? Yes, they are similar. Now, they're not the same size. You could say that and argue that, but they are similar because they'd have the same angles. Equilateral triangles will all have the same angles, so this would have the same angles as well. So just to recap on that lesson, so what we have come across is your introduction to Theorem 2. And Theorem 2 was based on, in an isosceles triangle, the angles opposite the equal sides are equal, and conversely, if the two angles are equal, then the triangle is isosceles. Also, don't forget your types of triangles, right? They're very important to keep in mind when you're answering questions. And then we went through a few different example questions of how you could work out missing angles. And then we looked at, now as I said again, you do not need to know the proof of Theorem 4 or Theorem 6. You just need to know how to use it as a reason for finding the measurement of an angle. And just to summarize, that Theorem 4 is the angles in any triangle add to 180 degrees. And each exterior angle of a triangle is equal to the sum of the interior opposite angles. So Theorem 4, the angles in any triangle add to 180, and each exterior angle of the triangle is equal to the sum of the interior opposite angles is this one. So the exterior angle outside here, angle 1, is always equal to angle 2 plus angle 3. So that is lesson 4, and I'll give you some examples then to look at, and that is geometry 2 really finished.